This is lesson IA5, and in this lesson we are going to multiply radicals. But before we multiply radicals, I'd like to review some of the multiplication of polynomials that you've done in the past. So we're going to start with just a little bit of review. I know that you remember the distributive property. If you had 5x, parentheses, 2x squared minus 3x plus 7, you would multiply the outer monomial factor times the inners, and that would give you 10x, that 10 does not look good, 10x to the third minus 15x squared plus 35x. So that's just to remind you of using the distributive property. I want to talk about FOIL. When you had two binomials, say you had 3x plus 7 times 2x minus 5, you did the product of the first, 3x times 2x, to get 6x squared. Then you did the outer product, which was negative 15x. You did the inner product, which was 14x. So you did first, you did outers and inners, but if they are like terms, you combine them, so that's negative invisible 1x. And then you do the last, which is a positive 7 times a negative 3 for negative 35. So that's the last. This was the outers plus the inners. I also want to talk about a special kind of FOIL called a sum and difference product. If you have 3x plus 5 times the difference of those, 3x minus 5, where the quantities first are the same and the quantities second are the same, but the signs are opposite. You don't do anything different with the FOIL, but something different always happens, and it will help you save some time. The product of the first, 3x times 3x, is 9x squared. It's the square of that term. Now, the outer product and the inner product turn out to be opposites. In this case, negative 15x and positive 15x, so there's really no reason to do them at all. Skip the outers and inners. Product of the last, since it's always going to be a positive times a negative, it's always going to be negative. 5 times 5 is 25. You get what's called the difference of squares, which came from the square of the first and the square of the last. Finally, I want to talk about squaring a binomial. Now, when you square a binomial, you can do it by FOIL, or you can use a shortcut. So I'm going to use a simple example. Let's say we have 2x plus 7, and I want to square it. Now, there are two ways to do it. If you do it by FOIL, then you would expand that to be 2x plus 7 times 2x plus 7. Product of the first is 4x squared. The outer product is 14x. The inner product is 14x. Add them together for 28x. The product of the last is 49. Now, what always happens when you expand something that's squared into FOIL is that the outers and the inners turn out to be the same. Well, this shortcut says, then why do it twice? Why not do it once and then multiply it by 2? So let me show you over here with the squaring process. Square the first one. 2x times 2x is 4x squared. The product of these is 14x, and that represents both the outer and the inner that we got over on this side. So if you recognize that, then simply double the coefficient for 28x, and then square the last for plus 49. All right, so I'm going to use those in this next lesson, but I will be working with radicals instead. There's something else that you will want to remember that I have written down here. When you multiply two radicals, you multiply the radicands. So if I have the square root of 2 times the square root of 3, that is the square root of 6. Typically, we're doing it in reverse when we're trying to simplify, but I wanted to remind you that that's how you multiply radicals. Then, something that's going to be extremely helpful to you, if you have the square root of x times the square root of x, I know that you're going to get the square root of x squared, which is back to x. So what I'm suggesting is you skip this step. If you have the square root of 2 times the square root of 2, just say it is rational 2. The square root of 9 times the square root of 9 is 9. All right, so I hope that those little reminders or content will help you. I'm going to erase all that. You could have paused the video if you wanted to take a minute to write those down. I'll go back. All right, let's take a look at these exercises. And I believe I'm going to take the lines off of this page. All right, for the first one, I have the square root of 3, open parentheses, the square root of 2, plus the square root of 10. In this problem, I'm going to use the distributive property. That's going to give me square root of 3 times square root of 2 is the square root of 6. The square root of 3 times the square root of 10 is the square root of 30. Before I say I'm done, I take a look at this radical. I cannot simplify it. I take a look at this radical. I cannot simplify it. They are not like radicals, so I'm done. That's the product. Let's look at the next one. It jumps in right away and asks you to square something, and it should feel like squaring a binomial. So I have the square root of 5 minus the square root of 2 squared. I'm going to do it twice. The first time I'm going to do it with the shortcut of squaring. Okay, so I'm going to use the shortcut. It says square the first one. The square root of 5 times the square root of 5 is rational 5. Then multiply these two. Positive square root of 5 times negative square root of 2 is negative square root of 10. But because that represents the outers and the inners, that's negative 2 square roots of 10. And then square the last one. The negative square root of 2 times the negative square root of 2 is going to be positive 2. I have rational terms there. I will combine them. Positive 5, positive 2 makes positive 7 minus 2 times the square root of 10. That's one way to find that product. The other is to expand it and do it by FOIL. You can call it the square root of 5 minus the square root of 2 times the square root of 5 minus the square root of 2. And I'm going to go ahead and write down every detail because you might find it helpful. First, it is the square root of 5 times the square root of 5, which is rational 5. The outer is the square root of 5 times the negative square root of 2, which gives us positive times negative is negative square root of 10. The inner, it is negative square root of 2 times square root of 5. Negative times positive is negative square root of 10. Last, I have the negative square root of 2 times the negative square root of 2. Negative times negative is positive. Square root of 2 times square root of 2 is 2. I will combine these because they are like radicals. I will combine these because they are like rational numbers. And I get 7 minus 2 times the square root of 10. And that's the same answer I got when I used a shortcut. It's up to you. Do it the way that makes most sense to you. All right, let's look at our next problem. All right, it looks again like it might be distributive property. I have 9 times the square root of 5 minus 4, and that's in parentheses, so I will distribute. This 9 is a rational number, so when I multiply it, I simply get 9 on the outside, square root of 5, and then 9 times negative 4, it's negative 36, and that's all I can do. Distributive property again. I have the square root of 2, open parentheses, the square root of 2 plus y, square root of 10, close parentheses. All right, I'm going to use that distributive property. The square root of 2 times the square root of 2, remember that gives us rational 2. The square root of 2 times y square root of 10, it's positive, keep the y on the outside. Square root of 2 times square root of 10 is the square root of 20. But before you consider any problem simplified, you have to look at the radicals in your final expression. Keep the 2 plus, I'm going to go over here. I have y square root of 20. That's y times the square root times the square root. 20 could be written as 4 times 5. And the square root of 4 is 2, so this is y times 2, square root of 5. Usually that would be written as 2y square root of 5. So coming back here, it is 2y square root of 5. So this was just my little work in simplifying. Always have to simplify radicals. All right, let's look at number 5. This looks very much like a binomial times a trinomial. So I will do it by FOIL. Product of the first. Now you may not need to write all this out, but I am to try to help and make it a little simpler. I have 6 times the square root of 7 times the square root of 7. Keep the 6. The square root of 7 times the square root of 7 is rational 7, and that's equal to now 42. The outer product, I'm multiplying these two. So I have 6 times the square root of 7 times 9 times the square root of 5. Multiply the rational factors for 54 and multiply the radical factors, square root of 35. Always ask yourself, can you simplify this? And the answer is no. Inner product. I'm going to multiply 7 times the square root of 5 times the square root of 7. So in case you're wondering, the inner is this times this. So it's going to be 7 square root, 5 times 7 is 35. These, by the way, are like radicals. I will add them to be 61 times the square root of 35. The last, I have 7 times the square root of 5 times 9 times the square root of 5. Here's the last times the last. Multiply the rational factors. 7 times 9 is 63. The square root of 5 times the square root of 5 is 5. Then, if you multiply those, you'll get 315. The first and the last are not always, but many times, both rational numbers. So if you add those two together, you get 357. And then I've already added the radicals for 61 times the square root of 35. All right, let's look at one more multiplication. I'm having trouble moving it. There we go. No, maybe I have more than one. All right, number 6, sorry. All right, this looks like FOIL, but I hope you notice that there is a difference and a sum of the same two quantities. Hopefully you remember that that means the middle term does become 0. All right, it just does not matter. It is equal to 0. So I have the square root of j minus rational c times the square root of j plus c. Product of the first, the square root of j times the square root of j is j. The outer and inner products will be opposites, and you don't need to take the time to do them. The product of the last, negative times positive, is negative c squared. So that one a little weird because it was all letters, but it does remind you about sum and difference products. It's going to be very important in problems coming up. Let's do one more multiplication. This looks like squaring, so let's do it as squaring. Square root of 6 plus quantity x squared. You can do it by FOIL. I'm just not going to. The squaring process, square the first one. Square root of 6 times square root of 6 is 6. Then find the single product here, which is x times the square root of 6. Remember that that is both the outer and the inner, so multiply the outside by 2, so it is plus 2x square root of 6. Square the last one for x squared. I know that that looks odd. Remember where this 2 comes from. You multiply the two terms. Know that that represents both the inner and the outer, so you have to multiply by 2 on the outside. None of these are like terms. All right, now we're going to rationalize denominators. Even though I use the terminology rationalize the denominator, this is actually the process for allowing you to divide radicals. We will not actually do any division, but what we will do will allow it to be the same as if you did do division. So suppose you had something like, I'm just going to make up a problem, doesn't matter what the numerator is, say it is 7 over the square root of 2. Now, because it's fractional form, rational form, I always think of division. But I have no mechanism for really dividing the square root of 2 into 7. So what I'm going to do is make the denominator into a rational number. I'm going to do that by the process that I have written here. I'm going to multiply it by the number 1. But I'm going to erase that because I can write the number 1 in an infinite number of ways. I could call it 9 over 9, 12 over 12, anything over itself. What I'm going to do is choose whatever this denominator is, square root of 2, over itself. Hopefully you acknowledge that that is a version of the number 1, but why did I choose it? Well, the numerator is simply 7 times the square root of 2. But the denominator, remember that idea that we've used over and over? The square root of 2 times the square root of 2 is rational 2. I know it's the square root of 4, but the square root of 4 is rational 2. So now I have an expression where there is no longer a radical in the denominator. This is how it's usually written. You could. My math lab doesn't like it, but it is the same as 7/2 of the square root of 2. That's not usually the form you find it, but that's what it means. So we'll get rid of that, but I wanted you to at least acknowledge that it means the same thing. Our goal is going to be make the denominator of any fraction expression into a rational number. No radicals. So here we go. Problem number 8, we have 1 over the square root of 2. I need that denominator to be rational. That means that I choose to multiply by the value 1, but it is going to be in the form square root of 2 over square root of 2. In the numerator, 1 times the square root of 2 is the square root of 2. The square root of 2 times the square root of 2, we will not forget, it is rational 2. And that is how my math lab would like to see that answer written. Let's look at number 9. Rationalizing this, I'm going to multiply by the square root of 2 over the square root of 2. That gives me the square root of 14 over, remember that multiplying those, you get 2. And it seems like every problem I did just then involved the square root of 2 on the bottom, but if I had the square root of 5 over the square root of 3, this is just a completely extra example problem, and I wanted to rationalize it, I would multiply by the square root of 3 over the square root of 3, which would give me the square root of 15 over, don't forget, rational 3. You cannot divide a rational number into a radical. That would be finished. That was not one of our example problems, but I felt like I needed to write it in there. All right. Remember when we practiced with sum and difference products? We had things like 3x plus 2 times 3x minus 2. And the neatest thing about this was that you multiply the first to get 9x squared, and you do not have to take any energy to multiply the outers and inners because they're going to be opposites, they're going to cancel. And then multiplying positive times negative is always going to give you negative. 2 times 2 is 4. When one of the two or both of the two terms is a radical, they're called conjugates. It's a funny word, but conjugates. So the square root of a plus the square root of b and the square root of a minus the square root of b are conjugates. You use this concept of conjugates to rationalize denominators that have more than one term but a radical in there. So I do not use that idea of whatever the radical in the bottom is, put it over itself. Instead, I use conjugates. So I have 13 over 2 plus the square root of 7. I'm still multiplying by the number 1, but this time it's going to be the conjugate of that denominator over itself. So in this case, it's 2 minus the square root of 7 over 2 minus the square root of 7. So in the numerator, we have the distributive property. 13 times 2 is 26. 13 times the negative square root of 7 is negative 13 times the square root of 7 over. Now, multiplying the conjugates. Remember that when you multiply the first, 2 times 2 gives me 4. When you multiply the last, square root of 7 times the negative square root of 7 gives me a minus, and it will give me 7. I did not do the outers and inners because I didn't need to. Therefore, the denominator here is 4 minus 7, which is negative 3. And I think we can leave the answer just like that. All right, let's do another one kind of like that. I'm supposed to rationalize the denominator, and I will do so by multiplying by the conjugate of that denominator, which is square root of 5 plus 2 over square root of 5 plus 2. This denominator, here is its conjugate. The numerator, I'm going to use the distributive property. That's 7 times the square root of 5 plus 7 times 2 is 14 over, all right, these are conjugates. Product of the first, square root of 5 times square root of 5 is 5. Last, negative 2 times positive 2 is negative 4. That gives me 5 minus 4 for the denominator, which is 1. We don't need to write that denominator of 1, so I have 7 times the square root of 5 plus 14. All right, let's take a look at number 12. If I'm going to rationalize, make rational the denominator, because there are two terms, I'm going to use the conjugate, the square root of 5 minus the square root of 2. The square root of 5 minus the square root of 2. In the numerator, I have the distributive property. That's 5 times the square root of 5 minus 5 times the square root of 2 over the product of the first, square root of 5 times square root of 5 is 5. The last, it's always going to be negative because one's plus and one's minus, and that's going to be 2. And so I will put it over 3. I will mention to you something that could happen. It didn't in any of our problems, but what if you had? I'm not going to do this whole problem, but I want to mention it. Suppose you had the square root of 2 plus the square root of 3 over the square root of 7 minus the square root of 2. And somebody said, would you rationalize that? You would say, okay, let me focus on the denominator. The conjugate is the square root of 7 plus the square root of 2, square root of 7 plus the square root of 2. And the reason I wanted to mention this example without doing the entire thing is that each example here in the numerators, we got to use the distributive property. It is possible that in multiplying the numerators, you might have to use FOIL. The first, the outer, the inner, the last. And so the numerator could be rather complicated. The denominator will always be pretty easy because it's always going to be conjugates. So although we don't have one of those, I wanted you to think about it. There is one other thing that I wanted to mention before I leave this particular unit on radicals. It's something that was not brought up before. Our first unit had to do with lots of review topics, and one of the big ones was exponents. So what I want to do is connect the idea of exponents and radicals. There is a connection. It was not discussed earlier. It will come up later in the course. If you have x and you raise it to a fractional power or rational power, that is by definition the square root of x. So we've seen negative exponents, we've seen positive exponents, we've seen 0 as an exponent. If you see a fraction, the numerator is the power of the base, the denominator is the index. But we don't write powers of 1, we don't write indices of 2, and that's why it just looked like the square root of x. So if I had 7 to the 1/2 power, what I'm really talking about is the square root of 7. If I had 9 to the 1/3 power, in this case, I'm talking about the cube root of 9. So finally, I'm going to say if you have x to the a over b power, then that is x to the a, and you're taking the b root, or you could write it as the b root of x raised to the a power. Something to remember is that the denominator is always the index. The numerator is the power. It can be inside, it can be outside. We're not going to use that right now, but I hope you listen to that in the video. This concludes our unit on radicals.